Okay, welcome to Forensic Investigations. This is an online session only with regards to file sharing. Um, what I'd like to do today is go through a little bit about file sharing, a little bit about peer-to-peer networks, P2P networks, how you can go about tracing file sharers, and what forensic artifacts you're able to find on a system where file sharing has taken place. And we'll start off with a little bit about the background. So file sharing is the sharing of any digital file over a network. Historically, it's typically been copyrighted material such as movies and music, and there are a variety of different methods that can be used in order to share files. So it may be that there's some central server somewhere that you're able to download these files from. Very easy to see where the server is, very easy to identify the server, very easy to connect to the server. Also very easy to take that server down if it happens to be hosting copyrighted material. And then we have decentralized methods where we have peer-to-peer networks. That means that someone who obtains part of the file is then able to share that part of the file with somebody else on the network. It's very difficult to find out where those parts of the files are. That tends to change quite rapidly. It's very difficult to take down the sharing of data via this decentralized method. And then we have sort of designs that are hybrid methods, so combinations of the two. Now, historically, we have an application called Napster. And we're around about 1999 here, so this is created by some guy, Sean Parker. And it was a very successful MP3 sharing service, a desktop application. There was some centralized server, some user registry, and you're able to log on to that. And then once you've logged onto that, you're then able to share files between one another. So I would be looking for a file, I don't know, Aqua Barbie Girl, then go on. So I'd like to find this file called aquabarbie-girl.mp3, then find peers that happen to have copies of that file that I could then download copies of that file from. Now at its peak, there are about 25 million users, 80 million songs. So for something that is, I mean, what now, touching 20 years old, and bear in mind that internet connectivity, and also internet speeds that people had access to were really quite poor. That is quite impressive. It was really quite famous. Now, unfortunately, Napster was sued by the RIAA that the users of the Napster software were directly infringing their plaintiffs' copyrights. That Napster were liable, and that Napster was liable for contributory infringement, and that Napster was liable for vicarious infringement. And the reason why is that Napster was sued, and as you can see on this slide, Napster actually lost. So Napster produced the mechanism whereby people were able to do the sharing, where people were able to do these acts. Unfortunately, they lost, and very soon afterwards they disappeared. Slightly ironically, as Gareth notes here, is that the court case gave Napster huge publicity, and the numbers of users increased as a result of this. Oh well, there we are. So what do we have then moving into the early 2000s? There was an interest in decentralized protocols. So Gnutella was the first decentralized peer-to-peer network. We then had 3net that was created, BitTorrent was then created, Pirate Bay emerged, Mega Upload emerged, lasted for a few years, made someone an awful lot of money before its servers were seized, and then launched in a new form. So we've had a large number of this sort of file sharing structures around. And for the UK, at least, breaching copyright is not a crime, but you can be sued. However, it may be criminal if you do this for profit, if you import copyrighted material, or if you make or possess equipment for copyright infringement, and a whole lot of other things. So generally speaking, yeah, if you are downloading stuff or you're allowing stuff to be downloaded from your computer, yeah, it's bad. You may not go to prison for it, but you may receive a letter saying, "We'd like you to give us lots of money." Now, Nutella was a fully decentralized peer-to-peer network. So this was sort of the base of the concepts that we used in BitTorrent, where you're able to take a file, you can then share that file between whoever you like, and it's very, very difficult because there's no central server to stop that file being shared or to shut down the Nutella network. In essence, I mean, what could be done? Yeah, in ISPs, but ISPs in a coordinated effort worldwide could block access to port numbers that Nutella software was using. However, it's then quite trivial just to change the port number. So that, you know, anything that is fully decentralized, that is very difficult to pattern match, that is very difficult to identify, is obviously then difficult to stop and to shut down. If you wanted to join a network in Nutella, you must be able to find some other node, one other node, that you can then use to get lists of other peers on the network. You may be able to get access to web cache, you may be able to use ISC in order to find information. And you then want to connect to all possible candidates for whatever it is that you wish to, whatever file you wish to get access to, until you have a few successes. And then the Nutella network attempted to maintain some fixed number of connections at all times. Now, this this network was, okay, it's decentralized, it's relatively inefficient because you search the network by flooding the network. So if you're looking for a Batman, assume that's a Batman movie, you'd send that to all of your neighbors within the network and they would do the same. And then that would continue up to a maximum of 7 hops. There was something in the Nutella network called ultra peers. And these are nodes that have been op, so they've been powered on for a long time and they have good connectivity. Around about this time, ultra peers were commonly associated with universities of all things. Universities tended to have good bandwidth and they left their computers on all the time. It is possible to build a large hash table of keywords and locations and to share that with other ultra peers, and then you end up with this sort of, you have a decentralized network, but you do have some form of centralization because you have some management using these ultra peers. And this sort of algorithm for decentralized networking, in order to get complicated things to happen, this is a fairly common design now. You would have some rendezvous points, some central places that are highly replicated across the network. You're then able to access one or more of those in order to find out more about the network underlying it. When you actually want to transfer files using Nutella, you're able to have a direct connection, so you're able to identify the IP address of the client which has a file that you wish to share. You directly connect to it and you download it. If you wish to push a file out, some clients are firewalled, so they can't connect. They couldn't accept incoming connections. We can send a request to a remote client computer and it connects to us instead. Both of these are actually traceable. Now I'll move on to BitTorrent in a little while and give a demonstration of what you would find, or what you should find if you're using BitTorrent on your host machine, if you're using peer-to-peer file transfer protocol of some kind, and you haven't just load up Wireshark and have Wireshark running while you're downloading stuff. So BitTorrent is really well known now. It was designed for the transmission of large files. It's used extensively nowadays for the transmission of copyrighted movies. It's used extensively as well for the transmission of image files, large image files. There have been a variety of different statements made about how much BitTorrent traffic is occupying the internet. And there's one here as well. There's no reference to this, but it's estimated to account for 40 to 70% of all internet traffic. I've heard a whole variety of different things said over the years. ISPs and the Akami Internet Report is something that can give you information on this. And I believe that their report might show that to be significantly lower now that there's so many people using HTTP in order to access things. In particular HTTP in order to access video on demand. So Netflix, Amazon, BBC iPlayer, all of this sort of stuff is now generating lots of traffic that is legal. There are a large number of BitTorrent users. It is used to distribute legitimate files, although apparently since 2010 over 200,000 users have been sued for copyright infringement. Geez, that's a lot. So, sharing on BitTorrent, you're going to create a .torrent descriptor file. You can distribute these via any means you like, email, the web, whatever else. This .torrent descriptor file describes the file you're trying to share, the computer it sits on. And this can be described as being a seed. This file is then divided into pieces. Each is hashed, so these pieces can be easily identified. And others can download these pieces. It doesn't matter what order they download the pieces in. They may be sequentially, they may not be. But BitTorrent specifies that it should try and download the rarest piece first. And as soon as the piece is downloaded, that piece should be shared with others so that they can be these pieces can then be downloaded and sustain the peer-to-peer network. So the computers with these pieces are called the swarm. So these are computers that have the ability to serve pieces of this file that wishes to be served. And peers with complete files are called seeders. So these are the computers that are able to provide any piece that any other computer wants of the file that is to be shared. I have an image next, and that image shows one computer with a seed seeding a load of other computers, and those other computers then pull various pieces of the file until that file is shared amongst the entire swarm, amongst the entire set of computers. So here we have a nice PC at the bottom that has 6 segments, and they're colored from sort of green down to dark red. And these 1, 2, 3, 4, 5, 6, 7 other computers start off this image not having any parts of the file. And you can see at the very first animation, red and green segments are shared, other segments are shared, and these segments are then slowly shared around all of the other machines. That's the principle behind your peer-to-peer sharing. So what you tend to find with BitTorrent is that unpopular files vanish. They take a long time to download. They don't have any seeders. It's really hard to find stuff that is unpopular. I've been searching for a video called Aggro Man for some years now, and I can't seem to find it. It's an old BMX video. However, for popular files, and popular files tend to be, well, movies that have just been released on DVD, there tends to be a high amount of redundancy for these. So it's quite easy to identify and download files that are very popular. There are some websites that are used to track torrent files that will give you the ability to identify who you can download these files from. So ISO Hunt is one, Pirate Bay, etc. Users can upload torrent files, and then the website is able to keep track of the members of the swarm. Other users can download this torrent file listing the current members of the swarm, and it does provide some degree of centralization, but only for locating the members of the swarm. The alternative is something that's used in Tor, which is distributed hash tables, but BitTorrent is seen to be fairly resilient. The problem from a forensic point of view is that it's very difficult to identify remote users. So We have a public-facing IP address here, 148.197.4.2. We have a NAT user. We have a NAT, so a network address translation router. I apologize for the text, which appears to be one little bit down. Well, as you can see, it doesn't appear to be too bad on my computer when we do that. Only when we display it. We're there, good. So if we have traffic that is being natted, and that means that the actual PC that is communicating isn't identifiable from the IP address that is publicly visible, it's difficult to be able to say which of these PCs is generating this traffic, because that traffic is being has the address being translated. So that means that in order to identify file sharers, we're going to have to seize a PC in order to identify whatever we can from that PC, which may well be the installation of some software to enable file sharing. It may be .torrent files. It may be, gosh, network traffic captures. I don't know. If we have a look at, and I think what I want to do next, my internet appears to be really quite slow, but let's see. I have a peer-to-peer TV capture here, so this is not illegal information being transmitted. This is using TV that is being broadcast and shared using a peer-to-peer network. So what we can see here is a general, well, you can probably tell how I was capturing this information. It's 192.168.1.11 as a source address, sending information out to lots of other IP addresses. So I am sending parts of information of live TV streams to other IP addresses, and then receiving information from a whole different variety of IP addresses here. And then every now and then, one of these IP addresses that I'm attempting to send stuff to or to capture stuff from will go down, and we have an ICMP packet being received here saying destination unreachable, because presumably they turned off the application that they were using or whatever else. Destination unreachable, communication administratively filtered. So we can see actually, well, being able to say how many other peers am I communicating with. This entire capture, which off the top of my head I believe is about 20 minutes in length, I communicate with over 100 different peers, and there are about, off the top of my head, about 20 that provided around about 80% of all of the traffic to my computer. Now I don't know if that 20 that provided the 80% of the traffic, whether 80% of the traffic is redundant or not. But it's very interesting to have a look at network streams of peer-to-peer shared files. So I think one of the things that will be good for you to do is to capture some peer-to-peer sharing of a file of some kind. Of course, I would promote that you do this with a file that you own, or a file that is certainly, by sharing it, you're not infringing any copyright. There are other software that you can use. There's FORIN that enables anonymous file sharing. It's impossible to track where files are stored. They pass through intermediaries. This really leads us on to Tor. Tor isn't really a file sharing network, but it does anonymize. Well, it doesn't really anonymize your traffic. What it does is anonymizes you, or attempts to anonymize the source of that traffic and the destination of the traffic. The traffic itself, of course, is going to be encrypted, and as a part of that encryption, it may tell something about what type of traffic you're sending. It uses a technique called onion routing, and that means there's a nice little picture down the bottom here. We're going to have a client system of some kind, some proxy, some onion proxy. We're going to enter into our onion cloud, into our Tor network. And as we go into our Tor network, we're going to use different machines in order to hop from one to another. So we are overlaying another network on top of the internet. and our routers on that other network are individual PCs that are then doing some very nice encryption things that are attempting to anonymize our IP address, anonymize our target IP address, as well as encrypting the information that we're sending. The bad thing is, of course, if you do belong to, if you do use Tor, your computer may be used as an exit node. An exit node is something where if you're accessing websites that are particularly naughty, your IP address will be recorded by your ISP as accessing that website and by the website itself. Other things of interest: news groups, old school discussion forums based on the NNTP protocol. Geez, I mean, you may find stuff like this lying around nowadays. I'm really not too sure. I certainly haven't seen it or used news groups for way over 15 years. And what artifacts are you going to find on the hard drive? Well, this is important. Each program is going to have some shared folder of all the shared and download folders in. You may want to search for deleted files too within your shared or your downloaded folders. There may be registry artifacts, recently downloaded files, recently accessed files, URLs. There may be evidence of software that has been installed on the machine. There may, from the most recently used lists, there may be something that you can say that a file has been used or played using Windows Media Player. So you may be able to find these sort of forensic artifacts on the hard drive image that you have to look at. So, in conclusion to this, BitTorrent is currently the most popular file sharing protocol. Users are relatively easily tracked because it doesn't hide your IP address. There's no mechanism of hiding your IP address, although it is quite difficult because of the sheer volume of users, particularly if you're sharing very popular files. The usage of file sharing will leave artifacts of different types on the hard disk. So you want to have the file that is being shared. You may have some file that describes that, called the .torrent file. You may have access to websites that will detail .torrent files and users that are participating in the sharing of this file. And those are the sort of things that I'd be expecting you to find from your image. Thank you very much.